Alright guys, so welcome. Today we're going to go over another problem in the linked list series. This one is problem 206 on LeetCode called reverse linked list. This is something that you guys should all learn and understand how to do. It's going to be useful for many other problems that we can, attack and solve using the methods that we learned for linked list. The problem reads, given the head of a singly linked list, we want to reverse the list and return the reverse list, right? One of the brute force things that we can do is just go through the list, traverse through the list once, and as we're traversing through the list, we store each node value in an array. Once we reach the end of the list, then we can get that, we have that array, this array that is actually we get the linked list in the form of an array. We can reverse that array, which can be done easily in Python. And then we would store that reversed array into a new linked list and return that new linked list. Problem with this is that even though it would give us a solution, we're going to take up more space than what's necessary, right? That would require extra space for the list that we're creating, where we're going to store the values as we traverse through the linked list once. Is going to have us reverse that list, meaning like the array, right? Reverse that array. And then it's going to have us have additional memory for a new linked list where we're going to put the reversed array values into that new linked list. That's going to take us O of n time in terms of space complexity. We want to do this in constant space, O of 1 space. Now, one way to do this is a method that is something that you'll find elsewhere. You notice that if I draw the linked list, like the first problem, right, in terms of these blocks right here. So say I have these blocks, okay, and I'm gonna do these with just do this with 4 elements just for the sake of time, right? And we know that each node has a value, right? About 1, 2, 3, 4. They have a next pointer here. You know that the list looks like this, right? These next, the next pointer points to obviously the next element, right? Now what we can do is we can do this in constant space by keeping track of 3 variables, right? And the other problems that we've done so far, middle of the linked list, determine if the linked list has a cycle, we've only kept track of 2 pointers, slow and fast. In this case, we want to keep track of 3 pointers, right? We know that the end of a list obviously has a value of none, right? Or null, however you want to look at it, right? It has that value of none which is the tail of the linked list, okay? Now, in order to reverse this, all we really have to do is move the way these arrows are pointing, right? These arrows need to actually be pointing this way. Does that make sense? Where initially, if we have the same blocks, we have the arrows pointing this way. This was originally the head of the list, but now this would be the tail of the list, with one exception, that this next pointer has to be none. Okay? And the head needs to not be none. Now, how can we do this? Well, we can do this, as I said, by keeping track of 3 variables, right? 3 pointers. The first one that we need to keep track of is previous, okay? And this needs to be set to none because this is going to be the previous node that we're at, okay? The next one we need to keep track of is our current position, our current node. And this is obviously going to be initialized, the head. And then we need to keep track of the next pointer, right? The next node. Well, what is next going to be? Next is simply going to be current.next. Okay, that's going to be the next node. Now, we don't want to initialize next. Be careful to not initialize next before our loop, right? We always want to have a while loop, okay? But before the loop, we want to keep track of next in the loop, right? Because as we're doing each iteration, our next pointer is going to change, right? Same thing with our previous and our current, but we can initialize previous and current before the loop because they're going to have initially a value of none, and current is going to be head because we're going to be working with that linked list head, okay? Now, we can do this by keeping track of the 3 variables, right? So say initially previous is here, our current will be here, and our next node is going to be here, okay? What we're going to do is say that when this is like the first iteration, let's say, right? We have our next pointer pointing to 2, our current at 1, and our previous is none, okay? So what we're going to do is we're going to initially set next node to be current.next, which we did here. Now, our current.next pointer, meaning this pointer here, we need this pointer right there to change its position. We want to change it to point to previous, right? Where here is essentially none. Okay. Then we got to update previous and move previous to our current position. And then we want to update current and move that to our next node. We restart the iteration again. Set next node, current.next. Okay. Set our previous pointer, right? Or set our current.next pointer, which is now this pointer. Set that pointer to previous. Okay. And update previous. Okay. Redo the then now current.next is equal to next node. Again, the new iteration. Update next. Okay. Now update the current.next pointer. Right? So that's going to be this one here. We're going to set it to previous. Update previous to be equal to current. Okay. And update current to be equal to next node. We're going to do this one more time. We're going to move next node. Set the current.next pointer to point to previous. Update previous to be where current's at. And update current to be to the next node. Now we're at the end of the list, right? We're at the end of the list. So our list is going to be true. Like we're going to perform this while loop while what? While current is true, right? Because when current reaches into the list, it won't be true. It's going to be none. It's not going to have a value. Does that make sense? Then we're going to do the logic here. Form some logic, which is what we did in each of these steps, right? And what do we want to return? Notice where our pointers are at. We have next is at none, current is at none, but previous is at the end of our list, but it is now, previous is now our new reverse list. If we look at just the blue pointers, the blue arrows, notice where previous is at. Previous has a new list. And if I redraw that list in terms of circles to save time, it looks like this. We have 4 elements. Right? This is none. And this is 4, 3, 2, 1. This is previous. The variable previous. All we'll do is just return previous. Okay? I hope that makes sense. This would give us a time complexity, right? TC of O of n, where n is the size of list. Size of linked list, LL. Our space complexity is O of 1, right? We only need space. We only need have additional memory for 2 variables, which we know is very small. So we could just leave that as O of 1, right? Let's go ahead and go back to our problem here, okay? The first case that we want to handle is when the list is empty, right? So if head is none, if the list is empty, what do we return? None, right? If there is no head, we just return none because reverse nothing is going to be nothing. I hope that makes sense. Now we have our 2 variables. We said previous is going to be equal to the value of none. Our current is going to be head. Okay. Now while what? Like as I said, while current is true, right? When current reaches the end of the list, we know that we are done traversing through the list, and we should already have, hopefully, our reversed list. Okay. So while current is true, our first iteration, right? If I go back to the drawing, our first step in doing this is we want to make sure if we're here, right? So if this is previous, right? This is current. Our first step in this loop is to set next node to be here, to be to current.next, right? That's why I said here that this will be inside the while loop and this would be outside of the while loop, okay? Because we're going to be updating next with the value of current.next, okay? Let's go back. So while current is true, our next node is going to be equal to current.next. Okay. And then we want to update the current.next pointer, right? The next pointer of current, we're going to set that point to be to previous, right? Previous is going to be equal to current. And then current will then just be what? Next node. Okay. And these 4 lines are going to do what I did in the drawing. At the end of this, when current is not true, meaning when it's none, it reaches the end of the list. We know that we have already reversed the list. and we're going to return previous, right? We don't return head. If we just return head here, what's going to happen? We're going to return the original list. Okay, 1, 2, 3, 4, 5. We don't want to do that. We don't want to return current because current is going to be at the value of none, right? We return previous because previous now would be at the position before current, right? When we're done with iteration, current is at none, the end of the list, and previous will be at the position before it, meaning it would be at this position where 5 is at, and it's going to have pointers that point to everything before it. And that's the redrawing that I did at the bottom. If I pull this up again, that is this drawing right here. All right, so I hope that made sense. If we run this, this is okay, this is good. Submit this, and we're done with this problem. Okay, so thank you guys for watching. I hope you enjoyed. Have a great day.